In this example, we want to determine if people using Weight Watchers actually gain more than 0 pounds when they're on Weight Watchers. So right away, we know that we're going to be testing a claim about some mean value, where the mean value is the mean weight loss. Notice that in this problem, we do not know the population standard deviation. So since this is unknown, this is a reminder that we are going to use the t-distribution instead of the normal distribution. So I have a bell-shaped curve below to represent the t-distribution. And this t-distribution is very specific. It's going to be the one for degrees of freedom of size n minus 1. So here our sample size was 40 people. So that's 40 minus 1, or degree freedom of 39. So let's go ahead and go through the hypothesis test here. First thing that we're going to do is highlight the claim. So we want to test the claim that the mean weight loss is greater than 0 pounds. So let me translate that into symbols. That means that mu greater than 0, and that's 0 pounds. Notice that this statement does not contain the equal sign, so it doesn't contain equality. That means that that statement is going to be the alternative hypothesis. So let me go ahead and write that down. Mu greater than 0, and keep track that this is the original claim. And then the null hypothesis will be the claim that the mean weight loss is 0 pounds. Okay, so on the bell-shaped curve on the right, let me go ahead and write down 0 pounds in the center. So that's our null hypothesis value. And we're testing the claim that people on Weight Watchers lose more than 0 pounds. So if we take a look at our sample data, we can see here that from 40 people using Weight Watchers, the sample mean was 3 pounds with a standard deviation of 4.9 pounds. So 3 pounds, I'm going to write that on the distribution here, X bar of 3 pounds. Well, that is greater than 0 pounds. Okay, so why can't we just stop here and say, hey, look, there's proof that people on Weight Watchers lose more than 0 pounds? Because look at the sample mean for this sample of 40 people. It was 3 pounds. 3 pounds is clearly greater than 0 pounds. But what we have to ask ourselves is, where does this 3 pounds fall on this distribution? So does it fall close to 0 pounds? So should I mark X like somewhere there, like close to 0 pounds? If X bar is this close to the null hypothesis value of 0 pounds, then we can say that, well, we see a difference in the mean weight gain, but maybe that difference is just due to chance. So we never want to make a conclusion based off of chance. So what we need to test right now is we need to test to see if this difference of 3 pounds, if it's really significantly different from 0 pounds. So does it fall like on the right tail of the distribution, like really far away from the center? And the only way we'll know is we have to calculate the test statistic and the p-value for this sample mean value. So to do that, so let me just move that off to the bottom here. We just know it's on the right tail. We're going to have to calculate our critical value if you're using the critical value method to make a decision about the null hypothesis, or we're going to have to calculate the p-value. So let me go ahead and go down to step 3 here, and let's calculate our critical value. So our critical value is going to be a t sub alpha divided by 2. And the reason why I'm dividing it by 2 is because the alternative hypothesis contains that greater than sign. So this tells me that I have a two-tailed test. So I'm looking for t sub, and then our significance level here is 0.01. So that's 0.01 divided by 2, or t sub 0.005. Okay, so on your calculator, you can use inverse t for this. Type in 1 minus 0.005. So that's the area to the left of 0.005 on the right, and put in the degrees of freedom of 39. Your calculator will give you a critical value of 2.71. So let me mark that on the distribution here. It's going to be a really, really small area in the left and the right tail. So that is alpha divided by 2, or 0.005. That critical value on the left is going to be the negative value, negative 0.271. And then on the right, let me try and shade in an area of similar area to the right of alpha divided by 2.005. And then that critical value on the right is positive 2.71. Okay, now what we need to do is we need to calculate the test statistic, which is a t-value. So I need to know, what is the test statistic that corresponds to our sample mean of 3 pounds? And then what is the probability of that happening? So what's the p-value? I'm going to show you how to use your calculator to get these values. So the calculator function that we're going to use is called a t-test. So let me show you real quickly here how to get to the t-test on your calculator. You're going to go to stat, tab over to test, and it's your second option, option 2. So choose option 2. And here it's going to ask you to type in all the information that you have. So your null hypothesis value of 0 pounds goes in first, then your sample mean, sample standard deviation, sample size. And then this third line here, make sure that this matches up with the alternative hypothesis that you wrote in step 1. So notice it's mu greater than 0. So here we would choose mu greater than mu naught, where mu naught is 0. So make sure you actually highlight that third option. And then when we go down and press calculate, all right, we'll get the results of the t-test. So take 2 seconds to double check to make sure that the alternative hypothesis is the correct one that shows up on the t-test. The next thing that you're given here is your t-value, which is the test statistic. So here our test statistic is a value of 3.87. And then P, this is your p-value. Pay really close attention to the p-value. Recall that a p-value is a probability, so that means that it's always a number between 0 and 1 inclusive. So when you see this number 2, notice that 2 is greater than 1. So that's a reminder that you have to keep reading the entire number to make sure that you know how this number is written. So this is your calculator's way of writing really, really small numbers in scientific notation. So I'm going to write it down on our handout here. 2.0026 e to the negative 4 is your calculator's way of writing this number in scientific notation. So this is really 2.0026 times 10 to the negative 4, which is the number 0.000200026. So that number right there is actually your p-value. It's a very, very small decimal, okay? And then because it's so small, if you're using your the p-value method, this will tell us to reject the p-value, or excuse me, reject the null hypothesis. So right away, let me go ahead and just mark. So I'm exaggerating here, but let me mark our test statistic of 3.87. Oh, I wrote it on the wrong side. So this is positive, so it needs to be on the right tail. So let me fix that. Let me put that on the right tail here. So all right, so our sample mean of 3 pounds has a test statistic, a t-score of 3.87. Notice that that falls in the critical region. And then our p-value is the area to the right of that. So I'll shade that in green, but it's on both sides. So notice that our p-value is really, really small. So our p-value is this area on the left and this area on the right. So we add those two together, that makes up your p-value. Okay, so let's go ahead and write down our conclusion or our decision about the null hypothesis. Okay, so here we can see that the difference that we see in our sample data, 3 pounds, it is different from 0 pounds, and because it falls in the critical region, it is statistically significant. If you're using the p-value method, we can see here that since the p-value is less than our significance level, so I'll write that down, 0.00020026 is less than 0.01, right? We will also reject the null hypothesis, okay? All right, so because our results are statistically significant, we're going to reject the null hypothesis. So what on earth does that mean? Let's go back to step 1. We're going to reject the claim that the average or mean weight gain for people on Weight Watchers is 0 pounds. This means that our evidence supports the alternative claim, which is also the original claim. So we would say in conclusion that there is sufficient evidence to support the claim, and then I'm just going to rewrite that claim in words, that the mean weight loss is greater than 0 pounds, right, for people using Weight Watchers. So I hope that you can see how a hypothesis test helps us see whether or not differences in our sample data are significant or not.